I do have a little warning. I do have a lingering cough from when I got the virus a while back. So hopefully it doesn't hit me, but let's see what happens. 15 minutes. I think I can survive it. So yeah, real-life end-to-end building, testing, and deploying of a buzzword-heavy application. I was looking at the list of the different hallway talks, and I have the longest title. So I don't know if that means anything, but at least it means that I need to make this possibly shorter. But I was looking at it trying to think, is there something I should cut? And I decided against it, even though it is a mouthful. I decided against it because I do think that the example I'm going to be showing does touch on all of these different aspects. It is real life. It's a real client. It's a real application we are building. We do end-to-end. There is no manual work involved. Everything is automated. We build, we test, and we deploy. And it has all the buzzwords. So we'll talk about that in a minute. But yes, my name, Eugene Romero. I am a senior cloud and DevOps engineer, and I work for in Norway, we call it Capgemini. I think in English, they usually call it Capgemini. But anyways, you might have heard of us, a big consulting company, originally from France. A little bit more about myself. I've been in the infrastructure and software development world for about 15 years, a little over that, getting old there. Also a Linux nerd myself, so that's why this entire world of DevOps and automation and all that, it just fits like a glove. It's exactly the stuff I like doing. And my education is in electronics, actually, so when I'm not working with software or with DevOps, I am usually restoring and modifying old gaming systems, especially Game Boys. So if you like to talk Game Boys, come look for me after we can discuss. All right, so let's talk a bit about the project that I will be discussing. First of all, the client is the Norwegian Maritime Authority. So this is a public sector client from Norway. And already when you say public sector, sometimes people start to lose interest. But in this case, in Norway, in the public sector, they have a very big push for making everything modern, for going cloud native, and they're actually throwing money at this. And if there's one thing that Norway has, is money. So they're throwing money at this problem, and they're actually coming up with some good solutions, right? So this is a client. The application is an online solution for sailors to obtain their licenses. Turns out that when you're a sailor, a professional sailor, I should say, you need to have a license depending on what it is that you do on the ship that you work on. So because of that, there is a system, there is a set of rules that you have to follow. There is maybe some different courses you have to take, or some education, maybe some experience, amount of hours on a ship. So all of these things, it's very structured. But up until now, this was a manual process where when someone wanted to get whatever the next license was for their career, they would have to send in a bunch of paperwork. Someone would have to do this manually. So we've been automating this whole process for them. And the reason, yes, because it was tedious, it was manual, and in the end, it's just a bunch of rules, right? So it's if this, then that. If he has so many hours, then he might be available for this, or eligible for this, or if he has taken this education, so on and so forth. I did talk about buzzwords, so we only have 15 minutes. Sadly, I cannot do an entire build and demo of our application, but we do use all of the main ones in this application. We have microservices, very big thing. Everything runs in Kubernetes inside of Azure, so we use, or Azure as I've heard the Brits call it. So we use the Azure Kubernetes service there. Everything with the infrastructure is set up as infrastructure as code. We, of course, follow only DevOps methodologies. Everything is cloud native. There is nothing on premises. So quite buzzword heavy, we could say. And, of course, the one that brings us here today, Terraform. Everything that we do with Terraform. And it's been quite a challenge because all of these bits, they are all modern DevOps things, but they are also different things, right? They're not necessarily the exact same category. So it has been interesting trying to use a single platform to be able to deploy, build, test all of these different bits. So why did we choose Terraform? First of all, simplicity. And when I say simplicity, one thing that I mean is that we wanted to have a single tool to perform all of our DevOps tasks. We didn't want to have a bunch of different tools that we had to learn and maintain. Also thinking about the ones coming after us, maybe we're onboarding new people, or if I'm moving on to the next project, the new person, will they be able to pick up on these systems? And as we all know, the more tools you have, the more complexity there is in this system. Also, too, we enjoyed the provider availability that there is in Terraform. I think I saw earlier today 2,000-something plus providers on the Terraform registry. And of course, it doesn't mean that they are all necessarily of the highest quality. A lot of them are custom-made by people. But we did find that there was enough providers for basically all of the things that we wanted to do within our application. Terraform also is fairly easy to read and understand. The syntax is quite clear once you have an idea of what it is that you're looking at. I mean, we know that I don't have to get into this too much, but it is simple to more or less know what it is that we are building. And finally, the documentation. We have enjoyed this very much. The different providers, especially the official ones, have very clear documentation that tells you clearly what things are. So we have managed to use this quite extensively and almost on a day-to-day basis when we are developing on Terraform. We are going on the Terraform documentation website and always comparing that stuff and comparing it to the different things that we use with, let's say, Azure or Docker or any others. Very good. So what are some of the components of our application? First of all, we have multiple identical environments. And this is something that you've probably heard about a lot, that it is an advantage. Also, companies don't always want to do it because of cost, because of other things. But by leveraging Terraform, we have managed to use or have a development, a testing, and a production environment that are identical. However, of course, saving costs. So for example, something might be smaller or a development model in our dev environment, while it might be a production, let's call it type or model in our production environment, right? But the beauty of it is that we can use the same, there it is, same Terraform code for all of our environments. And this is very important to us. We don't want to have different code that deploys to every environment. Because, as you know, once you start having different code, something that happens in one place is not going to happen in the other place, and you're not going to be able to figure out why. So this is important to us. And what we do then is that we have different variables per environment. So as we have our pipelines that deploy first to dev, then to test, and then to production, we just feed variables that tell the pipeline, OK, for this environment, I want you to create this and this, but I want these many of them, or I want this SKU, whichever. One thing we do then is we do our compliance and integration testing in our dev environment. This works for us because we are a small team. We have noticed that if the team grows a lot, we will have to change this a bit because, of course, once you have different people developing in the same environment, sometimes their changes are going to get in each other's way. But for now, we are a small team. This has been working for us. So what we do, we take our code, we take our Terraform, and we apply it, or first of all, we build it. We do some compliance testing. You might have heard of a tool called Terraform Compliance. If you haven't, it's not an official HashiCorp tool, but it is available online. It is well maintained, and we have found it to be quite useful for us because our client does have some regulations around compliance, the way things need to be named, where things have to be deployed, so on and so forth. So we do our compliance testing in our dev environment, and if that passes, then we actually do a deploy or a Terraform apply of our code in that dev environment and just run a smoke test, make sure that nothing blows up, make sure that nothing explodes. If we are satisfied there, then we perform our system and acceptance testing in the test environment. So this means that this is a little bit more stable environment. This is where the client can go in and see what it is that we are developing. We, of course, use other things such as feature gates and so on so that we only show what we want to show. But this makes it so that we have an environment that is very similar to production. Our client can go in, they can make sure that it looks the way they want it to look, and also we can make sure that we are building what we want to build before moving this code over to production. Something else that we need to make this work is to separate our infrastructure and application pipelines. And what exactly is it that I mean by that? This means that we have found that having our infrastructure, which is, let's call it the things that the application runs on, can be the Kubernetes cluster, can be storage accounts, etc. This is deployed on one pipeline. This is deployed on its own. And then the things that actually deploy our application, this can be our Docker microservices into Kubernetes. This can be our APIs into an API management solution. This is then deployed in its own pipeline. There's a few reasons for this. The first one is we wish to reduce complexity. If there is one thing that is true about Terraform is that it can get very verbose very fast, right? It can get very noisy and you end up with lots and lots of files. We wanted to reduce that as much as possible, so we figured that separating these two things would make it so that you didn't have so much code to maintain on each one of these code bases. Also, we wanted to avoid dependency issues. It does happen that at times, especially when it comes to that application layer, when we are going to deploy certain things, these things depend on things that already exist. They might need to get some data about something, or they might need to get some information about something. So we have found that creating it as we create the other resource that it depends on does not work. So therefore, we separate these. We have one set of pipelines just for the infrastructure. We have then the other set of pipelines for the application itself. Let's get into that in a little bit more detail. So the infrastructure code and connected pipeline then builds and deploys our Azure infrastructure. And these are just some of the components that are in there. It could be an API management gateway. It could be an elastic pool of a SQL databases. It can be an Azure Key Vault, an Elasticsearch instance, and so on and so forth. These, we can say, are the things that the application runs on, right? We don't necessarily configure them too much. We might configure them some, of course, but only what makes sense, so that we can have, let's say, an empty skeleton that our application will now be deployed into. Then the next side of it is the application code and pipeline, which builds, tests, and deploys the application components. So as mentioned, this can be the APIs. This can be the things that run inside of Kubernetes. So for example, we use Linkerd, or it can be Prometheus, all the different bits that actually make up the application. Our microservices as well, these are built as Docker images. We publish them to a Docker registry in Azure, and then by means of Terraform, we pull them into Kubernetes and set them up. Our database migrations as well, we have those scripted. By means of Terraform, we are also able to run those in our databases. So what are some of the providers that we use for this then? As I mentioned, we did enjoy the fact that there are many different providers that you can use inside of Terraform. So for example, we use the Azure AD and Azure RM. Both of these are official Terraform providers. And these we use for all of the main Azure things, right? So anything we need to do with Active Directory users or service principals, we can use Azure AD. Azure RM, creating anything inside of Azure. We also use Helm, Kubernetes, and a custom one by an internet developer named Gavin Booney. I'm sorry, if you are here, I am destroying your name. These we use for Kubernetes itself. As you know, Kubernetes, it is its own little microcosmos. So it does require a lot of also tinkering and massaging it. So we use those three providers to create anything and everything inside of our Kubernetes clusters. We also use a few helper tools, such as Random, TLS, or another custom one called PKCS12. This we use especially for things such as secrets, certificates, all of these kind of things that we don't want to be generating ourselves. An important note here, of course, all of these things, do remember that anything and everything you create in Terraform will be reflected in the Terraform state. So I'm not going to get into that because of time now. Of course, you should always make sure that you are keeping your Terraform state secure. But we use this for things especially such as internal certificates and so on that we know that we can protect and we don't need to be thinking too much about manually renewing. And finally, we use the external and null providers for things such as database migrations and custom scripts that there might not be an existing provider for. Very good. So a few of the challenges we have found, let me get those up there. It is not a perfect world. It has been running very well, but of course there's always room for improvement. We have things, for example, such as whenever there's changes in the Azure API, it might be that something in the provider that has been working no longer works because Microsoft has released something new. Usually these things get resolved fairly quickly, but for this we have found that it is important to keep our providers up to date. Something similar with the Kubernetes API. As you know, this is something that is still in development. There's a lot of beta APIs and so on. So we find that this is something that we constantly have to stay on top of. Sometimes some custom providers we find maybe work for us in the moment, but after a year or two, they are no longer maintained. So it can be that this becomes a challenge. And also this kind of goes hand in hand with some specific edge cases where we might need to use a script here and there, for which we might have to use, again, the external provider or maybe a null resource and so on. And finally, doing local development against a remote state can always be complicated, especially for new developers, because we want to have a central state, right, that everyone works against. But this can get complex when you're bringing new people in. So this has been an ongoing challenge as well. Some of the wins we have experienced, however, first of all, speed has been one of the biggest ones. We have reduced deployment times from days to minutes. And when I say days, I'm talking about some of the older applications that this client had, where a new release meant having a 4 or 5 page document for things that you had to manually do before performing a release. Now we just press the release to production button, it is done. So this is something that they really value. There's also a lot more trust in the environment and also in our disaster recovery. We even go every 6 to 12 months, we'll go in, we'll get a new subscription and actually deploy everything into it and see where it breaks. Usually things will break because this is like herding cats, so there's a lot of moving parts all the time, but at least we know that in case of emergency, that will be working for us. And finally, visibility. We have an increased understanding of the workings of our application and our infrastructure. We have found that sometimes with Azure, if you create things through the portal, Azure will create things in the background and not tell you about them because it will simplify this for you. But then you come in and start wondering, how does this work? Or what is connecting this bit to this bit? By writing our infrastructure as code, we have then found that we understand a lot more what all of these different moving parts are so that we too can stay on top of them. So that's it. My Twitter, the Eugene Romero, my website, dam.engineer. So I usually write in there about Terraform, cloud, Linux, whatever catches my fancy at the moment. I do have some stickers, so come find me later and I can give you one of those. That's it.